Hello, today's lesson will be covering distance in the coordinate plane part 2, lesson 14.1. We will be covering pages 402 through 405. So if you need to pause the video and get your math book out, I will see you in a moment. Okay, today's standards are going to be covering the same ones as our last video, NS8 and NS6. I can graph points on a coordinate plane, and I can reflect points across the X and Y axis. And I am going to add, in addition to that, today, this is also part of NS6, I can calculate the distance between points on the coordinate plane. So that's the new thing that we'll be doing today as part of NS6. So let's get started. Okay, we're going to be going over a problem from page 402. This is number 3, and then we're going to do an additional example. How to find horizontal distance. So we are going to plot 2 points. The 2 points are going to be point F. You can't see that. Point F is going to be the coordinates of 5, 7, and we're going to plot point E, that over here. That's going to be the coordinates of -4, 7. So if we remember how to plot points, you should be getting good at that. You had your homework that you had to do for that. We have the X axis and we have the Y axis. Put X on this side, I'll put Y on top. No, you can't see that exactly. So let's plot our 2 points. So let's plot point E, -4, 7. Remember that the -4 is the X coordinate. The 7 is the Y coordinate. So -4 is here. 7 is going to be up between the 6 and the 8. So we have to go up to where the 7 and the -4 meet. So that point is -4, 7. And then the other point we have to, if I can get all that to show at once. The other point is 5, 7. So 5 is your X value, and that's going to be on the positive or the right side. There's 5. 7, we're going to have to go up again because it's positive. So we find the 7. We find where the 5 and the 7 meet. That is 0.57. Now, we want to figure out how far apart these 2 points are from each other. What are their distances apart? So let's take a look at this. So this is, we're going to also give this a point name. This is E, and this is F. Help us call it something. So point E, from here to the y-axis, how many units is that? Well, let's count. 1 unit, 2 units, 3 units, 4 units. So from the point to the y-axis is 4 units. Now, how many units is it from the y-axis to the F point? Well, again, we can count. 1, 2, 3, 4, 5, right? Make sure I counted that right. 1, 2, 3, 4, 5. Yes, I did. So that's 5 units. So how can we figure out how many units E is from F? What is this whole distance? What do you think we would have to do to figure that out? Exactly. We would have to add 4 plus 5. 4 plus 5 equals 9. So it's a total of 9 units apart. or a distance of 9 units. That's how we would find horizontal distance. Okay. Pause the video if you need to get that written down. If you have graph paper, that would even be more helpful to have right at this point. I did put some on the Google Classroom for you to print off if you needed. Okay, now I'd like to show you how to calculate vertical distance. So we're going to take 2 points, and I'll write them up on top this time. I think we'll see better. This will be point G and point H. Point G is going to be 0, -5. Point H is going to be 0, -10. Now let's plot those points. So point G is at 0, -5. So 0 is my x-coordinate. Where is 0 on my horizontal? Exactly, right in the center. Where is -5 on my vertical, my y-axis? Exactly, going down, so between the 4 and the 6. So this point is actually right there. Now what about point H? Where is that? Well, the x value is 0, so it's going to be right there. And the H point is -10, so that's going to be right here. So this is point G. The coordinates are 0, -5. And here is point H. The coordinates are 0 and -10. Now we have to figure out how many units apart they are. What is their distance? Well, let's take a look. We don't have to worry about an x-axis or a y-axis in between them, so we can just count. So we go 1, 2, 3, 4, 5. How many units vertically apart are they? They are 5 units. So what we can say is what we did is take the absolute value. This is what we did mathematically. We took the absolute value of -10 and we subtracted it from the absolute value of -5. Do you remember all that stuff with absolute value we did at the beginning of the year? The absolute value of a negative number is going to be a positive number always. And the absolute value of a negative number over here is going to be a positive. So it's 10 minus 5, or 5 units. And that's what we got when we counted. So it's fine to count, but if you start getting big coordinates like 120 and 246, and the distance from that to 120 and 354, you need to be able to know how to use the mathematical formula rather than trying to plot your points always. So I wanted to show you that. Okay, now I'd like to do our guided practice, page 404. And that is a page you'll have to turn in, so you're going to want to do the work with me. I'm doing it under the document camera. You have to just write in the answers on your paper. So the first question is number 1. I'm going to slide that down for a moment. You want to take the point 5, -2, and reflect it across the x-axis. So let's plot 5, -2. Let's go back up here. So where would 5, -2 be? 5 is the x value. -2 is going to be down below. Where do the 2 cross? They cross right here. So that's 5, -2. Now remember how we reflect points? We're actually folding our paper. Take this apart for a minute here. We're actually folding our paper right along. If it's reflected on the x-axis like it is, we're going to fold it along the x-axis and see where our point ends up. But yesterday we learned how to find it without having to fold our paper. So we're going to count units. So if we're going to reflect it across the x-axis, let me label the x here so we remember that, and the y. Let's think about this. If we reflect it across the x-axis, we're going to go like that with it, right? If we folded our paper, our point would end up somewhere over here. So how many units have I gone from here to the x-axis? Well, I'm at -2, 2 units, right? This is 2 units. Now, I know when I reflect across the x-axis, I'm like flipping the point from here to there. I'm going to go 2 up from the x-axis. So I'm going to count up. I'm going to be on this same vertical line. I'm still going to be on the 5 line right here, but my point's going to move up 2 from the x-axis. So let's count. 1, 2. It's going to go 2 up because this was 2 units below. So now it's going to be 2 units above. So if I put it 2 units above, it will still be on that same vertical line. It'll just move up horizontally. 2 units above the horizontal line. So that is our reflected point. What is the new coordinates of that point? The 5 will stay the same. Remember the rule? What changes? Exactly. The sign of the second one changes to +2. Okay, that's number 1. Number 2, we are going to reflect -6, 8 across the y-axis. -6, 8. So let's plot -6, 8. -6 is going to be over here, and +8, we're going to have to move up. -6, +8 is going to be right here. So that's -6, +8. And now we want to reflect it along the y-axis. So it's going to go from here to there. The point is going to go from here to there. If we're folding our paper, we would be folding it this direction along the y-axis. So we have to count units. How many units are we from here to the y-axis? Well, let's count. 1, 2, 3, 4, 5, 6. We are 6 units to the y-axis. So we know that our point on the other side has to be how many units from the y-axis? Exactly, 6 units. It's going to stay on the same line. It's just going to be 6 units. 1, 2, 3, 4, 5, 6. That's 6 units. And we'll put our point there. It's going to stay on this line. And what is the coordinates, or what are the coordinates of that point? Well, we no longer have a -6 now. We have a +6. What about the y value? Exactly, that stays the same. So remember our rule when we're flipping or reflecting across the y-axis? The x coordinates change signs. When we flip across the x-axis, the y coordinates change signs. So it's just the opposite of what you would be thinking. So if you're flipping across the y, x coordinates switch signs. Flipping across the x, y coordinates flip signs. And you can see how that works out visually as well. Okay, this is numbers 3, 4, 5, and 6 on page 404. You have 3 points plotted, an A, a B, and a C. And you're supposed to find the distance on number 3 between points A and B. So let's see if we can write that down. So number 3 is find distance between A and B. Okay, let's see, how would we do that? So we have to find the distance here between A and B. So we're going to go from A. Because these are on different coordinates, remember, I mean, different quadrants. Remember how I said this was quadrant 1, quadrant 2, quadrant 3, and quadrant 4. These points are in different quadrants. This is in quadrant 3 and this is in quadrant 4. So we're going to have to count units up into the y-axis. So let's count 1, 2, 3, 4, 5 units. So it's 5 units from A to the y-axis. Y there, so you see that? X over here. And now how many units is it from the y-axis to point B? Let's count. 1, 2. 2 units. So now to find the distance, and in your book, they have the absolute value signs, and then they have a box to fill in, like that. And then they have equals, so let's fill this in. So we know the units, the absolute value of 5 units plus the absolute value of -2. So actually, let's put the points in here. So this is 5, -2, just so you can see where the numbers are coming from. B is -3. And then this is point -2, -3. That's for B. C is point 1, -3. That's for C. Okay, so now we got our coordinates in there. So if you look, the distance between A and B is the absolute value of the x coordinate 5 plus the distance, the absolute value distance of the other x coordinate, -2. So then absolute value signs will then change to become 5 stays of 5 when you figure out the absolute value. -2 becomes, that's right, +2. And then the answer then is 5 plus 2, 7 units. And we figured that out up here anyways. We counted 5 units plus 2 more units gave us 7 units. The reason they take the absolute value is because this value is negative just because it's in the third quadrant. But you don't count negative distance. Distance is always positive. It's still 2 units away from the y-axis. It's just a coordinate of -2. So that's why you take the absolute value to make your distance positive. And then number 4 is asking us to find the distance. Find distance between A and C. Between A and C. Well, let's take a look at it. So A and C are both in the same quadrant. They're in quadrant 4. So let's see how we would count. Well, we start here and we have to get to here. We don't have to worry about a y-axis in between them because it's over on the other side. They're both in the same quadrant. So let's count. 1, 2, 3, 4. So that is 4 units apart. So in your book, they want you to fill that out. So they give you the absolute value signs. Let's put the blue on those. Give you the absolute value signs. And they have a minus sign in there. Okay, why is that? Well, they're both in the same quadrant. So now we have to take the x-coordinate 5 and subtract it from the x-coordinate of C, which is 1, right? So 5 minus 1, and we're going to take the absolute value of that because we're talking distance here. So if we ended up with 2 points that were on the same quadrant over here, we'd be dealing with negative numbers. We can't deal with negative numbers with distance. So that's why we use absolute value for our formula. 5 minus 1. Absolute value of 5 is 5, minus the absolute value of 1 is 1. 5 minus 1 is 4 units. And that's what we got up here when we counted. We got 4 units apart. Okay, number 5. See if this is blurry a little bit. Number 5 is asking us to plot the reflection of point C across the y-axis. So we're going to reflect C across y-axis. I'll put that in pink so we know we're doing it across the y-axis. So if we go back up to point C, we have it right. I'll move this down a little bit. Point C is right here. It's getting a little bit crowded. We need to reflect it across the y-axis. So we need to go from here to that side. So we would be folding our paper this way, seeing where the point comes out. So if we do that, how many units away is point C from the y-axis? Just 1, right? So that means it has to be 1 unit on the other side of the y-axis to be reflected. So we would do that, fill out our answer then. If it's 1 unit on the other side, that's going to be what coordinate? -1, right? Right? And then, so we could plot that. Let's just put that over here. It's going to be right, and it's going to get too crowded unless I use a different color. Let's use light blue. It's going to be right here, right? It doesn't look blue, does it? Use orange. So that is the reflected point C. So that would be C prime. I can fit that in there. C prime. And C prime then is at a coordinate of -1. What's the y value? -3. That stays the same. Here we are. And the question was asking us, what is the distance from point C to point C prime? So we got the coordinate of the point. What is the distance now from point C to C prime? How many units have we gone? 1, 2 units. So the answer then, put it in pink, the answer is 2 units. So, oops, so 2 units. So point C from C prime are 2 units apart. They're 2 units apart. And we could figure that out by taking the coordinates and taking their absolute values and adding them together. We can do that using the formula. Let's do that just to show you. What is the coordinate of C prime? Let's put that in real quick. The coordinate of C prime here is -1, -3. Point C was 1, -3. So they're in separate quadrants, so we have to add their absolute values. So we're going to go down here and we have +1 plus -1, absolute value, that equals 1 plus the absolute value of a negative is a positive, or 2 units. And that's what we got when we counted. I wanted to show you the formula. And I have to fit number 6 on here yet. Plot the reflection of point A across the x-axis. We're getting a little crowded on our graph here, but let's try. Number 6, reflect, what point was it? I think it was A, reflect A across the x-axis. So this time we're flipping it the other way, reflecting it the other way. So we'll reflect A across the x-axis. So let's go back up here. Here's point A. This time we have to reflect it that way. So we have to go the same number of units from the x-axis on this side. We have to go the same number of units above the x-axis. So how many units are we below the x-axis? 1, 2, 3, right? So we are 3 units below. You can see that. How many units do we have to be above the x-axis? Exactly, another 3. We have to stay on this line. So 1, 2, 3. I'm going to put a little pink dot there. 1, 2, 3. So that's going to be A prime, the reflected point. What are the coordinates of that point? Just draw that we went up 3 units. We went up 3 more units. So what are the coordinates of A prime? Well, we're at 5. That stays the same. And what does the y value turn into? Positive 3. So the old A was 5, negative 3. The new one is 5, 3. And I'll put the, now the question is asking us, what is the distance between A and A prime? The point and its reflected point. What's the distance? Well, we would add our 3 units plus our 3 units, or 6, right? 6 units. What is the distance of the reflection? Oh, nope, the question is asking us something different this time. It's just asking us what is the distance of the reflection from the x-axis. What is the distance of the reflection, this point, from the x-axis, not from A. So just to this point, and we figured that out, 3 units, we counted. The last question asked us the difference from one point, reflected point, to the other. This is just saying from here to there. So that's 3 units. So number 6 is 3 units. Okay, this is the same page, 404, number 7 and numbers 8. I've drawn this out for you. The question for number 7 says, Yoko walks from the library to the mall. How many city blocks does she walk? It says the grid on the map represents 1 city block. So each line is 1 city block, and she has to go from the library to the mall. So how many blocks is that? Well, this one we can just count if we want. So we will count. I'm going to use black on this, I think. So we go 1, 2, 3, 4, 5. How many blocks did she walk from the library to the mall? 5 blocks. So number 7, Yoko walked 5 blocks. Okay, that's number 7. Number 8, if Yoko walks 1 block in 3 minutes, how long does it take her to walk from the school to the library? How long does it take her to walk from home to school? So we have to go, there's 2 questions there. From the school to the library. Every time she moves a line, she goes through, it takes her 3 minutes. So we have to figure out how far this is, first of all. So let's count the distance. 1, 2, 3, 4, 5, 6, 7. So it takes her, so this is number 8. So she has to go 7 blocks. And it takes her 3 minutes per block. So we're going to times that by 3 minutes. So it takes her How many minutes to walk from the school to the library? 21 minutes. That's the first question. The second question says, how long does it take her to walk from home to school? This distance. Well, this one's a little tricky. I tried to draw this correctly. This point is not on a line, it's between lines. We know what this line is, right? This is -3, and this line is -4. And this line is this point is supposed to be exactly halfway between -3 and -4. So halfway between -3 and -4 is, we're going to label this point, -3.5, right? Because 0.5 means half, or -3.5 point. And that's our first point. And our y value of that is -3. So it's -3.5 comma -3. I'm going to put that like that. So that is our coordinate of that point. So we want to know how long it takes her to walk from home to school. Well, how many blocks is she walking? Now we got to figure out a little bit of a half in here. Well, from here to here is a half, right? And then she's got 1, 2, 3 more, right? So 3.5, but we don't want to go that far, so we're at a half. So here to here is a half. From here to here is another 1 whole block. So 1 block and a half more. So another way of saying that is to take the coordinates of these 2 points, and so we can put the coordinate of that point. That point is -2, -3, and we can take the absolute values of the 2 points. So our first point, and bring this up, is -3.5, and we're going to put that in absolute value signs, and they're in the same quadrant, so we're going to be subtracting the 2 points minus the absolute value of the -2 point, which is what we just did. We did a half and then another half. So then that becomes +3.5 minus +2. So I have to do that vertically. We already know the answer, but let's show that mathematically. So we're going to subtract 2, and we have to put the 2 and line it up. We'll put a 0 after it, so we line our decimals up. 5 minus 0 is 5, decimal point. 3 minus 2 is 1. So it was a total distance of 1.5 blocks, or 1.5 blocks, like we figured out. But the question says, how long does it take her to walk from home to school? It takes her 3 minutes per block. So we're going to multiply by 3 minutes. So we're going to take our 1.5 and multiply it by 3. So 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. We have 1 number after the decimal, so we have to go 1 place. So the answer it will take her is 4.5 minutes. Okay, I just wanted to show you the whole page filled in there. We have the answers here for number 1, number 2, number 3, number 4, number 5, 6, 7, and 8, the ones we just did under the document camera, just so you've got them there. And then what I wanted to do is go over the summarizing the rules. So the measuring distance rules. Remember how I said if they're in different quadrants, we have to do different things? So the X rule, grab my little spotlight here. If the 2 X coordinate pairs have the same X coordinate, so for example, they have 3, both coordinates here have a 3. The X coordinates are the same. A, if the Y coordinates have the same sign, so 5 and 8 are the Y coordinates, they have the same sign, they're both positive, Then you subtract the y coordinates. That means they're in the same quadrant. So you're going to subtract the 8 from the 5. 8 minus 5. So they'll have a distance of 3 units. Now, part B is if the y coordinates have different signs. And remember, the x coordinates are still the same. They're still 3. So they're both 3. But this time the y coordinates have different signs. 5 is positive, negative 8 is negative. Then when that's the case, they're going to be in separate quadrants. So you're going to add their absolute values. 5 plus negative 8 in absolute values is going to be 5 plus positive 8, or 13 unit distance. Let me show you how that would look. I've got that written out here. I want to just draw that if I can for you. It's an example. So the first one, let's draw a little coordinate plane. Oh, I don't want to use yellow. We'll just use yellow, whatever. So there's our coordinate plane. And then we would maybe have a point. So we have 3, 5. So that's about maybe here, somewhere in there. And then we have another point that was 3, 8. So that's going to be probably somewhere up here. And I could make my coordinate line a little bit longer here. There. Okay. So you notice how the points are in the same quadrant. So you're going to just, and I'm going to change my color. You're going to just subtract the 2 y coordinates. So that's that example. This example, B, is going to be, draw another coordinate plane there, and we'll put our dots. So we have different signs. So we have 3 and 5, which is probably somewhere about here. And then we have 3 and negative 8. That's going to be down in a different quadrant down here somewhere, right? So then the distance from here to there, we have to add the y values. We have to add the 2 y coordinates for this one and this one. Up here they were in the same quadrant, so we needed to subtract the y coordinates. Okay? That is when you have the same x coordinate. They're on the same vertical line this way. Okay, if you need to write that down, because I'm going to be clearing those drawings in a moment, go ahead and pause and write that down if you need to. Okay, I'm going to clear that. And now I'm going to go to the other rule. What is the y rule? Now we're going to have the same y coordinates, different x coordinates. So the y rule, if the 2 coordinate pairs have the same y coordinate, I'll just move myself a little bit here, make sure that we're okay. So if the 2 coordinate pairs have the same y coordinate and the x coordinates have the same sign, so we have a 6 and a 2 from our x coordinates. They have the same sign, they're both positive. Then we will subtract the x coordinates. 6 minus 2 equals 4 unit distance. I'll show you that right away. Let's draw a little coordinate plane. And first point is 6, 1. So it's going to be somewhere around here. The other point is 2, 1. So it's going to be right here. And it should be in the same horizontal line. Not easy to move it. Best I can do. It should be on the same horizontal line this way across. So when you do that, you're just subtracting the 2 x coordinates. So we're subtracting the 6, or the 6 minus the 2. And our distance is found by this direction now. And they're both in the same quadrant, so we're going to subtract. The second part says if we have the x coordinates having different signs. So the y coordinates are still the same. They're both 1, but we have different x coordinate signs. We have 6 and we have a -2. So we have a positive and a negative. Then you're going to have to add their absolute values. So we're going to have to add 6, absolute value of 6, plus the absolute value of -2, which is then 6 plus 2 equals 8. So let's see how that will look on the coordinate graphing plane. So we have the point 6, 1, somewhere over here, and -2, 1, somewhere over there. Should be on the same horizontal line. And the distance then is going to be from here to there. They're in different quadrants, so we're going to need to add their absolute values. So again, same quadrant, whether vertically or horizontally, we subtract. If they're in different quadrants, we add. Okay? So I'll share these notes with you. The drawings aren't going to be on there, so if you need to write those down, pause the video and write those down. I'm going to clear those in a moment. Okay? And number 9, the question was, how do you use absolute value to find the distance between 2 points that have the same x coordinates but different y coordinates? That was our first rule. So I basically gave you the rule. They were just asking about the x rule, but I also gave you the y rule. So now homework. So guided practice, page 404, we did this together on our video. So you should be able to turn that in very quickly for me. And then page 405, numbers 10 through numbers 18. So those are the ones you're going to be doing. I can probably bring that up. Move myself over here. So this is number 10 through number 18, and that's your page that you will be doing. So there I am. And I hope you like my new math background. So I'm experimenting around a little bit. And if you have any questions at all, please feel free to email me or call me or text me or anything you need. So I hope to see you again soon. Bye.